My name is David Brandt. I'm representing Cymer here at SPIE 2013 Advanced Lithography. Myself, I've been working with Cymer for 17 years and been on the EUV program for the past 8. So we're here this week presenting our results at SPIE Advanced Lithography because this is the premier event of each year, and it has been so for many years. Today we were very pleased to announce some key milestones in our EUV development program. Our systems have demonstrated up to 40 watts of EUV in continuous operation at high duty cycle. The recent developments on the laser-produced plasma system have incorporated what we call Mopa Prepulse technology. Mopa brings a master oscillator into the laser system for a precise controlled timing of injection of pulses through the amplifiers. Prepulse brings a conditioning of the target. That target is actually hit twice as it travels from the droplet generator nozzle through to the point where the plasma is created. The first low energy pulse expands the droplet, conditions the target per se. When the main high energy pulse hits it, it's a better match physically, and also as a density of the target is reduced, the coupling of energy is better. We get better penetration of the high power CO2 into the fuel, creating a higher conversion efficiency. So the efficiency of the system is increased with Mopa Prepulse. And our systems today in San Diego, we have 3 test systems that are sitting side by side. We can run all of them together. They're all in Mopa Prepulse configuration. We achieved several very stable runs just in the past couple weeks at the 40 watt level. 40 watts of average power at high duty cycle, operating in Mopa Prepulse mode with dose stabilities that meet scanner requirements, which is a bit better than plus or minus 0.2%. And then because we're operating on a scanner simulator, we can go back and post-process this data, look at individual dye exposures. We can actually calculate a yield over an entire lot or multiple lots of wafers. So as we presented today, we've achieved better than 99.7% dye yield on multiple lot exposure that extended over 6 hours at 40 watts. So we really met all the requirements of high power at 40 watts, dose stability better than 0.2, and dye yield better than 99.7%, which is the 3 sigma target. In addition to running the sources at high power, we also have to demonstrate the capability to keep the collection optic clean and free of debris, free of damage during that high power operation. It's not the actual collector that gets damaged, it's the coating on the collector. So coating protection is fundamental in the operation of a laser-produced plasma source. So we also tested that. We demonstrated with a raw power of about 60 watts, a run over multiple days that lasted 4 billion pulses. It's kind of the indication that there's no early damage mechanism, and the collection optic remained perfectly clean over those 4 billion pulses. Because EUV lithography is of such huge importance to the chip-making community and the world, the global manufacturing community, we do spend quite a bit of time in direct communication with our customers and hold very detailed reviews quite frequently. We held one of those reviews last week. The challenge that we received was, so go do it again. So this morning we were also pleased to show that we were able to repeat the performance and ran again at a continuous mode for 6 hours at 40 watts and met the stability requirements. So our systems are now capable of repeatable performance at this power level. This milestone represents validation of the capability of EUV source to work at the 40 watt level. We've also pushed it, because it did so well and it had some overhead room, we pushed it one step further and we operated for an hour at 55 watts. We got almost as good stability, about 97.5% die yield. So it was also quite good. There's some things we can do to match the stability at 55 watts with the 40 watt exceptional runs. And going forward, we're going to raise that steadily over time, all the way up to whatever the target is for EUV lithography. The next step is to go to 60 watts. Our three demonstration systems are what we call the 3100 style source. We have a new architecture which we've now introduced to ASML and are shipping and starting to ship in volume. That's a 3300 source. So with the 3300 source, we get a little bit more CO2 power, or a lot more CO2 power. So the equivalent of a 60 watt demonstration on our 3100 source will match well with the 80 watt requirement for initial market introduction on the 3300.